Ladies and gentlemen, please welcome Fielder Hiss.
Good morning, and welcome to our third and final day of SolidWorks World 2013. Did everyone have a good time last night at Universal's Island of Adventure? I hope everyone had a good chance to ride the adventures of Spider-Man and enjoyed the roller coasters and everything. I don't know how we're going to top yesterday. I think we had some great moments, some amazing technology, some very cool customers, and I still am just picturing the Festo bird flying around the room. We were maybe going to just do it for an hour and a half, but we thought it'd get bold after a while. But you know, really some great things. And today is really a day much more of technology. You know, our traditional theme for the third day of SolidWorks World. And as a part of that, one of the things you've told us is, and you've noticed this year, is you want to hear a little more from our partners. You want to hear a little more about the technology that they're working on and the things that they're doing. And the first partner we've teamed up with today is Dell. They're helping us in the office, on the field, and in the cloud. And to learn more about how Dell is helping SolidWorks users, please join me in welcoming to the stage Kirsten Billhard. Kirsten, come on up.
Good morning, everyone. It is such a pleasure to be here with you today. Thank you so much for the opportunity. This is actually my first time at SolidWorks as well. So it's been very good for me to learn a little bit more about the applications and the community that surrounds them. So most of you here, I understand, come from companies who make things. It could be consumer products, it could be medical devices, it could be automobiles. And my job at Dell is to understand you, the manufacturing customer, to understand the industry, to understand what's going on, what your problems are, and I bring that information back to Dell. I work with our product development folks to help them better make products that meet your specific needs. I work with our sales teams so that they can ask the right questions and help you with the technology that is most appropriate for the problems that you're trying to solve. And there are a number of things that come up again and again. First of all, for manufacturers, even a very small company can be global in nature. You may design in one part of the world, manufacture in another, and sell in yet a third. And you know what? That's hard. And customers around the world are only becoming more demanding. They want things better, faster, cheaper, safer. And for you, the designer and engineer, that's hard as well. And in manufacturing, when you look at the P&L, the largest expense is often cost of goods sold. And what makes that up is raw materials to a great extent. Raw materials such as iron or nickel or copper or oil, those prices, those costs, can go up and down, perhaps on a daily basis. And you have absolutely no control over that. But yet, your investors expect you to produce profit margins that go up year over year, quarter over quarter, and that's hard as well. And then finally, due to the global nature of the business, supply chains can stretch around the world. So suddenly a flood in one part of the world, political unrest in the third, just plain bad weather in another part, can disrupt your components coming in and cause you some serious problems in meeting your commitments to your customers. So all of this makes it just a fascinating industry to work in. And we certainly have a perspective on it. And at Dell, we believe that technology is incredibly important to enable you to help face these challenges that are facing you. So for instance, we believe that technology can be used to automate simple tasks and just effectively make them go away. This is called getting lean. And we talk about it on the factory floor, but it absolutely has a place in the engineering department, sales and marketing, even the finance teams. And technology has a place for that to help make that easier. We're all being flooded with data. I mean, social media came around and those channels are wonderful, but they flood you with all sorts of data from your customers. And how do you sift through that? Couple that with data that comes from your production environment, from your sales teams, from the industry itself. And technology is a way to help organize that data, pull it all together, and draw out a few critical insights that inform you on perhaps which customer features are the most important to bring out in your next product line, or which customer segments have the most opportunity for your business. Technology can support that. In terms of the supply chain, technology can create visibility. It can create visibility just in your own organization and make it easier to collaborate with the folks down the hall or perhaps on a different floor. And it certainly has a way to draw windows through walls so you can see through, from a technical perspective, to your supplier, to your supplier's supplier, to your customer, and perhaps your customer's customer. And that allows, in that whole supply chain, the right person at the right time, at the right place, to have the right information they need to make the right decision, which makes everyone across the board more successful. And then finally, and most importantly for this audience, technology can do a lot to accelerate innovation. So we believe, just like SolidWorks, that technology is a huge part of enabling you, the designer and engineer, to go faster with the critical work that you're doing. And that ultimately is why we're here today. We believe that the world-class applications put out by SolidWorks need world-class hardware from Dell to optimize all the goodness that comes from it. So we absolutely would love to see you at the Dell booth. I would love to hear about the projects you're working on. We would love to hear your feedback on our products, what you like, what you don't like, so we can continue to deliver even better products that meet your needs. It's been a pleasure being with you two, with all of you. Have a great show and safe travels home. Thank you.
Thank you very much.
Thank you.
We really appreciate Dell's support always.
Thank you so much.
Take care. So again, thank you so much, Kirsten, and thank you very much to Dell. Dell's always a strong supporter of SolidWorks World, always a big participant. And each and every year at SolidWorks World, one of the things that goes on is one of the more exciting things. It's kind of CAD's version of the Roman gladiators, of people squaring off to test their talents and their merit. And that's our Model Mania contest that we have in the Partner Pavilion each and every year. To talk about this year's contest, please join me in welcoming Mark Schneider. Mark, come on up.
As Fielder mentioned, every year in the Partner Pavilion we hold a contest. It's a modeling contest. We ask you to sit down and make a part, and then we ask you to make some changes to the part and run some quick simulation on it. These are the past, this is our 14th year, by the way. These are the past 13 parts that we did. You can see the complexity isn't real great, but you got to remember, we only give you 20 minutes. So whoever gets it done fastest is the one who's going to be the winner. This year, this was our part, the one that we chose. That's the wrong text at the top, but that's the right part. This is Model Mania 2013. You can see the part just has a couple of big bosses on the side. So on the left, the drawing on the left is the one that is what we give you to model. So we sit down and model this part. Secondly, what we ask you to do is make a change to that. So you don't know what the changes are as they're coming. And then we ask you to make a change to that and then run simulation on that as well. So that's really that simple. So what do you get if you win? Well, you win some fabulous prizes that were given to us or provided for us by our sponsor, NVIDIA. So really high-end graphics cards that are optimized for SolidWorks. And this year, we're offering the Google Nexus 7 tablet with the Tegra chip in it as well. So those are really good prizes for this year. So without further ado, what we're going to do is we're going to bring our champions, our winners, up here on stage. So I'm going to call out the names of all of our winners, bring you up on stage, and I'll actually walk through one of the ways that you can go through and model this part and make the change and do the simulation. Start with our customers first. Third place winner, Richard Wan from NJ Engineering. Come on up, Richard. Second place winner is Tom Smith from CHL Systems. Come on up, Tom. And our first place winner with the fastest time of anyone was Sadikal Khalsa from Triaxial Design and Analysis. Come on up, Sadikal. Sadikal's time was 8 minutes, 45 seconds to do both the part, make the change, and the simulation. So really great time. Great job, guys. So for our resellers, by the way, we do separate resellers from customers. So our customers don't compete against our resellers and vice versa. So for our resellers, our third place winner is Michael Steves from Quest Integration. Crowd likes him. Second place winner, Sean Bentley from Desai Solutions. And our first place winner is Gordon Stewart from TMS CAD Center. So let's walk through how this part could be built. Obviously, everyone knows there's many ways to build the part, but that's the drawing that you're given when you sit down to go ahead and begin the modeling contest. So I'm going to walk through how this could be done. In my opinion, I think one of the strongest foundations of creating a good solid model is with a sketch. I think all these guys recognize that as well. So we'll draw out a couple circles on the screen. I'm just going to copy these. Use just Windows Select, Control-C, Control-V. Why did I do that? Well, because when I use fully defined sketch, it knows to set those circles equal to each other. Saves me a little step there. We'll go through and change some of the dimensional values for some of these items here to get it roughly in place. Next, we'll add some arcs. So we're going to put some sweeping arcs across here. Just use the three-point arc tool, draw out the geometry, and then we'll add some tangency to those as well. Speed through this. Again, some people like to separate out their sketches. I like to put a little bit more information in the sketch. Both are valid techniques. We'll set all those equal to each other, and we'll add a dimension to control the size there. Next, I'm going to actually add the offsets while I'm in the same sketch. Some people added ribs, some people shelled it out. Again, all valid techniques. We'll just offset that by 3 millimeters. And the reason I do this is because I'm a big fan of using contours. They're a very powerful tool inside of SolidWorks. Hope everybody takes advantage of them. As we extrude this out, go ahead and use some of those contours that I have in my existing sketch there. We'll drag this out 20 millimeters. So there's my first 3 bosses that I'm going to add. Next, we want to add some webbing to connect all of them together. We'll just use the same sketch that we had. All that information is packed in there. We can allow the sketch to solve itself in a very concise manner. Make that 3 millimeters thick. Again, using the same sketch again, drag out our ribs there. These are going to be 12 millimeters deep. That's the basis of the geometry. The last thing we have to do is filleting. I had a lot of complaints from people that said filleting is really hard. My only trick here is what I like to do first is I like to try to fillet a feature. In this case, I couldn't really do that. Then I go to faces. Then I use the edge selection. The other great technique for this one would have been to use the new edge selection pop-up that pops up when you're selecting edges. That's a very good technique for doing that as well. It's not necessary to add the colors to the fillets. I like to do it because it helps me visualize whether or not I've added all the fillets to the model or not. So that's it. Once you're done with this, what we do is we give you another drawing. Say, okay, you got your model done. Now you got to make some changes to that part. These are the changes here. So we ask you to make some changes and then run some simulation. If you look in the section view at the bottom on the left, you can see that some of the bosses are all shifted in relationship to each other. And we also shifted some of the webbing. So a little bit of a challenge, but it makes the part stronger. It makes it better for the simulation as well. We ask you also to run simulation, hold the larger cylindrical face, and then add a load to the cylindrical face on the left. So let's walk through how you'd approach this. Since we're moving the bosses around, we'll go back, way back into my design, and I need to move some of those around. I could use the offset capabilities in the extrude command, that's one way, or I could use the move body. Since I don't have move body on my toolbar all the time, I'm using the command, I'm using the help at the top to use the command search. Just go up there, command search for move. It gives me that feature right away. I'm able to move those 2 bodies back 4 and 8 millimeters respectively. Next, I'm going to remove from my webbing extrude one of the contours. Just take that out because that doesn't belong there anymore, and I'm going to need to add it back in. So here I'm going to use the offset capability in Sketch, choose the vertex to offset to, flip the side to extrude, and that'll be 3 millimeters. So again, there's the basis of the geometry. The last thing we need to do is deal with our fillets. When you make a radical geometry change like this, you can expect that your fillets are going to fail, so we'll walk through that, repick some faces. And we've actually added 2 additional edges. A lot of people missed some of these extra edges that were added there. Once you're done with that, there's your part. Everything's ready to go. Always take a little bit of time to study your part, make sure that you got everything done, completed, and you didn't miss a fillet here or there. Last thing we got to do is run our simulation. You're going to use, we give the contestants the ability to use either Simulation Express or SolidWorks Simulation. I'm using SolidWorks Simulation here. That's my preference. We hold down the larger cylindrical face, add a load to the smaller cylindrical face on the left, make that 500 newtons down, and then we'll go ahead and run our simulation. With the fastest solvers in the industry, we'll add a couple of seconds here, we're able to get our stress values, stress information. I like to use the animation. It lets me understand if my part is behaving as I expect it. In this case, it is. And then we'll just create a factor of safety plot so I can get the minimum factor of safety. Right around 3 for the number, if anyone's curious what the factor of safety was on the part. And that was the answer. What is the minimum factor of safety? So we graded all these guys on who had the most accurate parts then on time. You saw some of the top times that we had there. And again, let's give our winners one more round of applause. Come on up, guys. Good job, Richard. Prizes will be shipped, okay? I got your email address. Prizes will be shipped to you. Great job, guys. Thank you.
Mark, thanks again, buddy.
Thanks,
Great
Dylan.
job this year. Mark's so precise, he's the only person in the room that noticed the year was wrong, probably, but he still had to point it out. You gotta love that about Snyder. Now, moving from competition and battles, I want to shift gears to actually a true passion at SolidWorks, something that is kind of near and dear to our hearts. It's a big part of our culture and a big part of our values, and that's really education. It's something we're very passionate about. The community, it's a huge and vibrant educational community. I think Bertrand spoke earlier this week, the fact that 2.5 million students every year learn SolidWorks as a part of their design and engineering curriculum. There's no one at SolidWorks more passionate about education than our next presenter. Please join me in welcoming to the stage Marie Blanchard. Marie.
Thank you very much. 2.5 million. This week, we have seen you design without limits. On Monday, we saw Red Bull Stratus design team lead us on a successful mission to the edge of space. On Tuesday, we saw Vijay Kumar's robots, those autonomous swarming robots, jump through hoops, harmonize in music, and coordinate communication halfway around the world to Tohoku University in Japan on a successful search mission. And then there was the engineers from Festo. Who was not uplifted in our hearts and open our minds to that very smart bird? Students also design without limits. They have come from afar, all the way from Colombia this week, from the Universidad Militar Nueve Granada, and down the street at the University of Central Florida. They too share our passion. And we have heard stories from dedicated educators that every day inspire students in engineering design. They share the job-ready skills necessary with SolidWorks certification to be qualified for our talented commercial customers. And we have heard your stories from you, our customers, our resellers, and our partners. You have mentored students at your places of work and after-school activities. Our next guest is the SolidWorks mentor. He is an entrepreneur, an innovator, an inventor, and a chemical engineer. He uses his dream as leader of the Robot Mavericks and a visionary to allow space to be accessed by all. Let's watch in this video.
Each and every one of you were selected because you're really bright, you got good, strong scientific skills, from robotics to engineering to science. So we're actually going to take all the knowledge you guys have as a collective group, and we're going to apply it to build a rocket. What we're going to do with these kids here is we're going to make rocket scientists out of them.
I had absolutely no idea what was in store. Then I saw the syllabus and I actually saw, like, wow, they're actually going to be learning rocket science.
We said that's going to be our textbook, right?
They're going to be drinking out of a fire hose. Be careful what you wish for. You may get it. Next one. We'll get one for everybody else. They're going to be involved with everything from the design of the nose cone on looking at gas dynamics, performance envelope, propulsion systems. Basically, we've built a rocket, and it's ready to fly. So that's kind of the good news.
Is there bad news?
Yeah.
There's bad news. We got a weather hold, and I don't know how long you hold. Now that they've had some time, kind of the pace of getting everything done and ready to fly and pushing for the April flight window that just didn't work because of the weather, it's going to be very interesting to see their perspective on things.
Ladies and gentlemen, I'd like to welcome everybody to the Black Rock Desert. We're here to launch a very important project, and I'm here to conduct the safety briefing. My name is Wedge Oldham. Range safety is not flexible, nor am I. Are we clear on that?
Things will always go wrong. You don't really see it coming until it hits you, and when it's actually down to the line.
We want all the people that showed up with all the limbs and fingers that they came with to go home with those same amount of limbs and fingers.
Let's get the copper thermite. I need your help.
We have such a short window to launch this thing, and if the weather doesn't cooperate, we can't launch it.
This one powers the telemetry system.
1200 will put us at T-minus 45 minutes, and we're going to go from there, and we're going to be real.
It's really close coming down now. It's going to be fun. I've never done anything with one try. Something always goes wrong.
I swear to God, we need to get on this.
I get worried about everything.
Launch control, go or no go. We're at T-minus 1 minute. The time is 1:29. We are at T-minus 1 minute, waiting for Tom Rouse and the rest of people to clear the vehicle area. Stage go or no go.
This is wow, this is so intense.
And there certainly are a lot of risks and things that could malfunction.
Ladies and gentlemen, we are go for launch. All stations report ready in all respect. We are going in. We have permission to launch the vehicle. Launch. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Oh my God.
Please join me in warm SolidWorks welcome and welcoming on stage Tom Atchison from the Rocket Mavericks.
Wow.
Thank you, Tom.
Thank you.
Welcome to SolidWorks World.
Well, I want to thank you for the privilege of being here. I can't tell you how overwhelmed I am with the opportunity to speak with probably the largest group of the greatest designers and engineers and entrepreneurs like myself. I'm just floored to be here.
Well, we're glad you're here. You have a great story to share with us today. You're working with students in a really creative way. Could you tell us a little bit something about the Rocket Mavericks?
Well, the Mavericks got together probably in about 2005, 2006. It was some of the leading civilian space explorers. We were building vehicles. We all had that passion as our generation very much sat by the TVs and watched the launch of Apollo. That's why I became an engineer. That's why a lot of our friends became engineers. But still deep-seated in us was that desire to build something ourselves that breaks the Kármán line, which defines space. And in pursuit of that, what I found is that same value was shared by the community around me, but also the kids in my neighborhood. Now, so we formed this nonprofit foundation because what I found is through the act of working on these vehicles with us, there was an opportunity to inspire these kids to actually participate and apply what they learn in science and technology and engineering and math. So we formed the foundation in 2007, and the primary focus there was to leverage STEM education that they were getting in the classroom, but to give them a way to demonstrate their mastery of those principles by actually either succeeding or failing, which has a lot of educational value as well, and actually building and launching a vehicle into space. And as you know, space is kind of not this monolithic place. It's kind of got this area near space, and that's a great place for middle school kids to play with balloons. They can still get up above the blue line. It's beautiful out there. They feel like they're in space. The rockets are really well slated for high school students. They have the math and the science to actually conduct missions there. And then at the university level, both orbital applications and even now small spacecraft people are building and starting to look at actually getting out into the solar system and Lagrange points. But the big point of this program is there's lots and lots of rocket programs in this country, and they're really great. Families participate in them. But when you take a rocket and actually have design limitations for specific mission applications, you're no longer flying rockets. You're flying missions.
That's great, Tom. How did you go from chemical engineer and get your interest in space exploration?
Yeah, so it's a funny transition. As I mentioned, we were all kind of born out of this excitement in the Apollo program. I'm a chemical engineer who kind of got hijacked in Silicon Valley before computer engineering was really a discipline. I took a job with Hewlett-Packard in their research labs, and of course, as a scientist and an engineer, we had to write our own code. So I kind of got hijacked off into the software industry for a while. But after 25 years of that, and a number of companies that I did, I started to realize that I was a chemical engineer at heart, and I really hadn't done anything with my career there. And very similar to von Braun and Korolev in Russia and Goddard here in the United States, who all started building amateur rockets, I started building rockets. And the rockets got bigger, and my neighbors got more nervous. And the FBI showed up a couple times, and I got a call from Homeland Security, and then my homeowners association was upset because all their lawyers with those big, thick books of all the stuff you're not allowed to do, well, building intercontinental ballistic missiles wasn't in there. So anyway, so it got a little out of control, and I thought, well, maybe we need to find a safe place. And so I went and called up NASA and said, hey, my neighbor's a little bit nervous with these big missiles around. Maybe we should put them someplace that the public would be more comfortable. But I think, in my heart, there was still this desire to give back. And the kids were kind of, around, and the neighbors were a little nervous about having their kids around me at first. But there's a heart in me about mentoring. There's an image up here. This is actually a picture from my high school. This fine gentleman over here, that's Steve Jobs. And there's a group of us in Silicon Valley that were really touched at Homestead High School by a mentor. He was our shop teacher, and he inspired a lot of us to try to create the world that we wanted to live in. And we all carried that in different ways. And so I decided to take this and not only enable the ability to get the common man to be able to access space because of the technology it would have, but what I tried to do was leverage computational processing in a fashion where we can actually start reaching both orbital applications as well as suborbital launch vehicles.
Well, we just saw a launch, and we have a pretty technical audience here. I love talking with engineers all week, even though I'm a mechanical engineer and that, you know, the chemicals and mechanicals fight sometimes. But can you share with us a little bit about what the launch process is all about?
Well, so flying a mission, basically flying space missions, requires a couple things. First, you got to get out of the gravity well. You may want to not get completely out if you know, it depends whether you're doing orbital or suborbital type applications. But generally speaking, you're given a mission. It's either an orbital mission or a suborbital mission. And that mission has certain requirements. Like, for instance, the video that you saw here with the students, we're very interested in bioprospecting because we don't know how far off the surface of the Earth life really exists. So you get these mission requirements of a very specific thing that you have to do. And then the design process then begins. Now, many of these high school kids could never build a launch vehicle from scratch. Now, we help with that. And so we have a reference design. We pre-flight qualify. But then the students have to modify that design and in the process learn about how to build a launch vehicle or a spacecraft. And so we use the computational processing tools to take the requirements for the mission, translate those into design changes on the reference design, and then use simulation to visualize the impact of those design changes actually on the flight performance of the vehicle. So from there, we can then transition, once we have a design selected, we go ahead and take that, and we now have to convert it into machine tooling, build the vehicle, and that's the first half, as you saw there with the students, and we all sit around. And then there's the second half. And the second half is actually launching and flying it. And this is also a great opportunity, but we don't turn it over to NASA. But as you see, we got to deal with the same stuff NASA does. We had a little problem with moisture that spring, and so things got delayed a bit. But we get out there, we got to set up the launch site, they got to operate all those things, and launch the vehicle, run the mission, grab the data, bring back the telemetry, and then recover the vehicle, because these vehicles are not expendable. These are actually reusable launch vehicles.
A lot of details. So why in all of this did you select SolidWorks?
Well, so SolidWorks is pretty interesting. So what I was looking for was a single platform that we weren't going to have to spend a lot of times with the students focusing on all the details of all these different packages, simulation, computational fluid dynamics, FEA, as well as modeling, and then all the machine tooling, CAM, and all that. And so I was searching for something, and I got exposed to Frank Payton and Chris Miller out on the West Coast. And they said,
they're our resellers.
Yeah, and they said, hey, you know, you really ought to check out this SolidWorks package. And so we started looking in that, and then the development of the program and the designs. And it turned out that SolidWorks, unlike any other platform out there, really has, through a single interface, a portal into all of these, which is perfect for the education environment. Because once the students master that environment, whether you want to do your tooling with the CAM packages, the machine pieces, some of the new additive manufacturing capabilities with 3D printers that are coming, as well as the simulation capabilities, through one package there, they had access to all the tools they were going to need to prepare for the mission.
And this took your middle school kids all the way through high school and into the college program.
So the first session you have here is the high school students, and then they're preloaded for the university environment. Obviously, the launch vehicles are not being built by the middle school kids. Middle school kids are building the payloads that actually fly on balloons, but they still fly to about 130,000 feet, which is, you know, no drop in the bucket.
It's a lot more than the SS rockets that I used to do in the backyard and get in trouble with my mother. SolidWorks is really excited to work with you, and I am excited to announce today that on behalf of SolidWorks, this is a surprise, we didn't rehearse this, that we would like to sponsor your next mission.
Oh, wow. Thank you.
Surprise.
I guess the only question I've got for you is, who here is going to push the launch button?
I don't know. I think we should open it up to our customers to see. What else can they do to get involved?
Well, we need your support. If we're going to rebuild the space facility and kind of take the torch that NASA's passing off to everybody, we need all of you to support and join us. The skills everybody here has, there's no question any one of you couldn't build and launch one of these. We want to encourage you to do it. I want you to reach out to the foundation. We need your support. We need your company's support. But I think through all of the folks that are here and the schools and communities that they represent, we can rebuild an even larger space program and get humans out into the universe from the ground up rather than a national program from the top down. So I invite you all to join us, come to our website, tell us your ideas, and get started and have some fun.
Tom, thank you for joining us at SolidWorks World and mentoring so many students. And thank you for all of you who help out students around the world using SolidWorks.
Thanks so much.
Thank you very much. That was really cool. That was truly inspiring. Tom leaned over to me because I didn't see the rehearsals, and he goes, "Do you know what we do?" And Tom, I was blown away. In a way, I think it's a little bit of a call to action. I think this type of program really inspires the youth, gets them engaged in science, technology, and engineering, and is a great way for all of us to engage in our futures as well. Next, I'm going to bring up one of our partners. And this is a partner who's worked very closely with SolidWorks for many, many years. There's a partner that worked with us on our RealView technology, and this is truly someone who actually pushes the envelope, but also pushes us as well in bringing new technology to you, our users. So please join me in welcoming Andrew Kraishi from NVIDIA. Andrew.
Pleasure, man. What a great entrance, right? Fielder, thank you. Tom, I got to talk about that program. I saw a movie a few years ago called October Sky. It was inspiring about kids putting a rocket into space. And I come to this event, I was not expecting this, and you seeing the real thing. That rocket is in space. Inspiring program, you've done a great job. Chris, I also want to come back to Model Mania. You know, we sponsor Model Mania for a reason. My talk is called Powering Innovation, and this is just the heart of it, right? You guys provide the tools and techniques to create some great stuff. We do the grunt, and we do the horsepower. So hopefully, our job is to go build the graphics horsepower that makes the most complex designs you guys build and brings them to life. So a couple of examples. Motuses, and the lights are so bright I can't see if you guys are in the audience. You guys build the fastest things on the planet, and the goal is to build the fastest electric motorcycle on the planet. And I think you guys have talked about these guys in the past. This means you design at the edges of everything that everybody builds. You're going to push the limits. So they upgraded to the new Kepler 5000, and it just took the blinkers off. You use full screen anti-aliasing that gives you the best, crispest lines, solid, shaded with edges, real view on, everything on. That's the way you design, everything on, in the real world as it exists. That's the Kepler 5000. Trek were great. We went to visit with these guys, and we loaned a Quadra 4000, and some guy plugged it into a workstation that he thought was ready for the scrap heap. Brings it to life. Loved the machine, loved the board. We never saw the board back, by the way. But that's today. Things keep moving on. You guys keep challenging us, and you're asking us to do more. So when I come and listen to what the future brings, and there's a few examples already been mentioned on stage today. Timescales are compressed. You've got to do more in less time. Engineers that used to be doing component design are now doing assembly design. People who are doing assembly design have to simulate, because whatever you build has to be right the first time. Great examples of, I design it, I build it, I ship it. It's that fast. But how do you do that? The model is you get to the end of the day, you've got a big simulation, you hit simulate, you go home to your family, you come back the next day and you keep your fingers crossed that that simulation is finished. Oh, and by the way, that it actually was what you wanted. That's not so good. And then you're out at a customer site, and the customer says, well, could you just make this change? And you're going, what if I was at my machine? I could do that right now. Instead, you've got to come back tomorrow. You're at home. You've had a hard day at work, right? And something is just not quite right. And you have supper with your family, and something goes, I got it. I know how to fix that. And wouldn't it be great if you could just go do that change right now instead of waiting until the next day when you go in the office? There's so much left to be done. It's our job to go figure that out. I call this the future, but is it? So we've kept moving. Like you guys, we innovate all the time. You know, most of you guys in the audience already use NVIDIA, so you know us for graphics. So I won't spend too much time talking about that. Since then, NVIDIA, we're now doing a lot of work at empowering tablets, the Microsoft Surface, for example. Oh, this thing here. This is pretty cool, the Google Nexus. All right, tablets used to be for the elite. This is a sub-$200 device. I know a bunch of you guys are buying this and giving it to your kids for Christmas. But in talking to the teams, Fielder was very gracious in allowing us to come and show you something very different today. That's a Nexus, and you probably can't see on there that little thing up the top that says eDrawings. So here we got an Android device, and I'm just going to bring something up. And you guys, here's the first public viewing of eDrawings on Android. It's real time, it's fast, it's in alpha. The engineering guys are going, no, it's not real yet. All I'll say is this is coming to an Android device near you pretty soon. Great job, guys. What else is the screen showing us? Well, there's a couple of big-looking black boxes in the middle of the screen there. So it's a new evolution, right, which is using graphics for compute. And so the workstation-looking device and the servers, which are big clusters for simulation, those are all using GPUs. If you come, we're showing a lot of stuff on the Dell booth at the show, so please come around and take a look. But the workstation, it has a Quadro in it, which you guys are all familiar with. It runs SolidWorks at the speed of light. But it's also got a Tesla compute card. So now, you remember what I talked about earlier about simulation? You're running SolidWorks, you're doing your design. Then you hit simulate. So the simulation piece, you could be running an Abacus simulation, and it offloads it entirely onto the Tesla GPU. It takes it off the CPU, it runs it twice as fast as you're used to running it, but you keep running in SolidWorks in real time. Design and simulation at the same time. Oh, and on the right, what's a car doing on this picture? That's a Tesla, by the way, okay? So this is America pioneering innovation again, the full electric vehicle. But the same device, the chip that we put in the Nexus tablet, well, similar device, is in the Tesla. It's got a big center screen console, which is over 20 inches big. It's enormous. You know, there's going to be some litigation about getting distracted while you're driving, but it's a super quality display. All the instrumentation is variable. It's got a big sign on the top that says, new software ready to update. It's like driving a great big computer. Incredible. It's the state-of-the-art future stuff. If you haven't seen a Tesla, go check one out. But if you're driving a modern Audi, a modern BMW, Volkswagens, it's likely you've got one of our Tegra chips inside the car. Things are changing real fast. So, but that's not the end of it. The cloud, I know for most of you guys, everybody talks about the cloud, and it's a little ethereal. But something's changed. This is not for buying clothes or records or whatever. This is for you guys now. We made some huge innovations in the last year. I can now get graphics encoded on the internet and shipping out over the internet faster than I can draw it on the screen. SolidWorks on the cloud is a reality. So today, I talked about, there are customers, some of you guys out there run SolidWorks on a server or a workstation in some server room. And if you're sitting at your desk, you might just be using a monitor. You might be using a small laptop. And you're running like you've got a huge workstation by the side of your desk. But if you're at a customer site, you can log on as if you've got your workstation with you. After supper, you can log on at home. You can go use your kid's gaming machine. You can use your little laptop. And you can run SolidWorks as if you're in the office. It's a game changer, anywhere, anytime. But I saved the best for last. Can you guys run the video, please? So, is that a MacBook Air? That is a MacBook Air. We're using Citrix, and we're running SolidWorks on a MacBook Air. That's a big model. You know a MacBook Air is the lightest, coolest thing, but it's not powerful. But you're running the biggest SolidWorks model that's available. So just to prove, this is some guy in our office, that machine that it's running on is somewhere in, across campus somewhere. And this is commonplace today. So Citrix, NVIDIA, the cloud becomes real. You guys can innovate anywhere, anytime, any device. So come back to the presentation, if you could, please. Just to close, we have such a super relationship with you guys. Honestly, you're one of the most innovative, far-sighted companies. Everybody else in the audience, you guys are just pushing the boundaries and doing some real cool products. All I'll ask is you guys, if you think there's something standing in your way, come and ask Bertrand, come and ask me. We're going to build you something that'll get you over to the next level. Thank you very much.
Andrew, thanks so much. We appreciate the support as always. We really do. As you see, NVIDIA is a company that really is pushing limits and technology, moving beyond, in some ways, the things that we all know them for, as the GPU in your workstations, and really helping us understand applications of technology and moving things forward. This community and you, our users, are one of the biggest ways that we drive our software, the way that we develop, the way that we enhance, and the way that we think about things that are important. Listening to you is the most important thing we do. Bertrand reminds the organization of this regularly. Every year at SolidWorks World, we open up and give you the opportunity as a vehicle to let us know the things you'd like to see enhanced, added in future versions of SolidWorks, and that's our top 10. Here to reveal this year's top 10, please join me in welcoming to the stage Bruce Hallway. Bruce, come on up.
Thank you, Fielder. Thanks. So this is the 15th anniversary of SolidWorks World. My first World was 2002, Mandalay Bay, Las Vegas. And I was a customer back then. I'll never forget how much I learned, all the great people I met, and just what a blast I had. But it's amazing how far we've come since then. Particularly the product. You know, looking at the early versions of SolidWorks, it's like looking at an old family album. Life may have been simple back then, but you couldn't do a fraction of what you can today. Every year, the core modeling gets more powerful, and we add whole new disciplines to the product. You can now manage, analyze, share, and document in ways we couldn't have imagined. But through all of this change, there's been one constant, and that's the guidance of our user community, all of you. You know, in fact, our formula has been quite simple. Listen to our users, understand their needs, implement good solutions, and repeat that procedure year after year. Now, we have many ways of listening. We get thousands of enhancement requests every year, and we analyze every one of them. We constantly follow the forums. We do alpha testing and usability testing because sometimes we can see ways to improve the product just by watching you use it. We visit hundreds of customers every year, so we can see firsthand how you work, what you design in your own environment. We attend user groups, we do surveys, we inundate ourselves with feedback from you. But there is one way you supply feedback that's unique because it's so transparent. That is the SolidWorks World Top 10. So for those of you who are not familiar with it, it's an online forum in which anybody can propose an idea, see everyone else's ideas, comment on them, and vote for their favorites. Here at SolidWorks World, we present the 10 most popular ideas. So this year, we have some senior SolidWorks employees to announce the results. Let's take a look at the video.
Create auxiliary line for dimensioning angles.
Draw a line segment starting at the midpoint.
External thread wizard for all thread types.
Default the concentric mate for axis to cylindrical surface.
Option for equal spacing on linear patterns.
Provide a version of the eDrawings mobile app for Android devices.
Cylindrical mates need an option to lock rotation.
Two words, slot mate.
The ability to save SolidWorks files in previous versions. Backwards compatibility.
Make rebuild time faster. What do you think of that?
So there you have it. There you have it. The SolidWorks World 2013 Top 10. We've got our work cut out for us, but you should know that over the years, we've implemented the vast majority of all items on all top 10 lists. So please continue to help us make SolidWorks an even better product. Thank you.
Please welcome back Bertrand Sicot.
Oh my gosh, you know, look, it's already the end. This is what happened when you are spending 3 days with friends. Time flies so quick, right? So, and finishing with that presentation is clearly outstanding. So now you understand that SolidWorks 2014, the R&D team is working on some good things for you. So it's coming in the August-September timeframe, as usual. So quickly, on day one, we spoke about the future. And we also discovered the engineering team of the Red Bull Stratus. Yesterday, we enjoyed discovering pretty amazing robots, obviously with the birds flying around. And today, we discovered what a person with a passion sharing with students, they can do nothing else than shooting a rocket in the sky. This is clearly few examples of the creativity of the SolidWorks user community, you. This is designing without limits. And this was the theme of this SolidWorks World 2013, the 15th anniversary. Did you like it? So, where are we going next year for SolidWorks World 2014? Do you want to know? Yeah. OK, so let's run the video. We go back to San Diego in California. Well, now it's time to say bye-bye. Have a safe trip back home, and see you next year in San Diego. Thank you. Bye-bye.